All right, well, if you want to follow along via YouTube, you can go ahead and leave. If you're signed in, of course, you can leave some comments here and questions if you want. This is just a pilot. I've used OBS before. This is live streaming right now instead of recording it and posting it later. This is just in case we have to go to live streaming the entire time. But otherwise, if you want to go to that URL and tell me if my audio is working, because OBS says it's working, but I never trust it, and I don't have proper audio set up here right now for output. So, okay, great, thank you. All right, so now I need to get set up. There we go. All right, so today we're going to be covering Jdbc, starting to cover Jdbc. We'll probably get through most of it. But basically, it's programmatic access to your database. So everything that you've been doing with your database stuff up to this point in your labs, and hopefully as you're developing your project, it has been through an IDE, an integrated development environment like MySQL Workbench, where you type them out directly, and then you execute them, and then you can see them in the IDE. But of course, that's not how most applications actually work. Most applications programmatically access the data. So you write code that then automatically goes to the database, pulls the data, and processes that data. And most programming languages have some sort of a way to do this. C, last semester, if you were there, at the very end, you had a database lab, and that used ODBC, which was Open Database Connectivity API. Java is going to be Jdbc, Java Database Connectivity API. Most other programming languages have some sort of a framework or way of connecting programmatically to a database. Again, for Java, it's going to be Jdbc. What is an API? An API is an application programmer interface. This goes back to one of the solid principles in version of control, where we're going to program towards this API. Rather than programming stuff that actually connects to the database, we program towards an interface, and then we bring in the implementation of that interface as a jar file so that we can write code that will go to any database that we want. It could go to a Postgres database, it could go to a MySQL database, it could go to a DB2, like an IBM server or something like that. We only want to write code once. And then if we want to connect to a different type of database, that's where we bring in a separate jar file. So it's an inversion of control. Rather than depending on lower level dependencies like a specific database, like a MySQL database where all of our code is now tied to only MySQL, and if you want to change it over to Postgres, you have to rewrite everything. Instead of relying on those low-level dependencies, we're going to invert the control, and both of those things depend on an interface now instead. Okay? You don't program towards a specific database because then you'd have to rewrite it for everything. The vendors like Oracle, IBM, whoever puts these databases out, they will provide a driver library that you can use, and that's simply going to be just to download a jar file. Jdbc provides a lot of stuff, but the stuff that we're going to focus on are you need a connection. You need to make a connection to the database. You will prepare your statement. There are other ways of doing statements. I'm only going to show you this one because it's the only safe one. And then, of course, if you get results back, you have a result set. Right? So if you were to do this in MySQL Workbench, you can see a direct connection here, right? That when you set up your connection, that you were doing basically this. When you were preparing and executing your statement, you were typing in your queries. And the result set, that was the table that eventually appeared when you executed those queries. Right? There are also ORMs, which are object relational mappings, such as JPA or Juke or a bunch of other things where you don't actually write JDBC code. Instead, you make connections and you say that this class corresponds to this table over here, and this member variable corresponds to this column over here. and then it hooks up and connects everything for you. And if you're interested in doing that, I've got some. I've got a video on it, and then I've got not a bonus, but an extra lab that you can go through and check it out if you want. But otherwise, we're going to stick with regular old plain Jdbc. So I'm going to do this as a demonstration, demonstration tutorial. The first thing that you're going to need to do is you're going to need to download the connector from MySQL from Oracle. Again, these are provided by the database vendor. So I'm just going to go ahead and look for MySQL connector J. Right? And you'll see that it probably takes us to the same website as you downloaded MySQL Workbench from. Here we go. It's the current version is 8.0.19. Right? It doesn't matter. I'll go with platform independent since it's Java anyway. Java is inherently platform independent. Tarball or zip doesn't matter. I'll go ahead and download this. No, just start my download. Save file, and then I will show you that I've got it over here. There it is, and I had already opened it previously there. So a lot of stuff comes with this stuff. All you really need is that jar file. Okay. So what I'm going to do is I'm going to bring it into my project here, right? And copy the files, and then of course right-click, just like you've done with all of your jar files up to this point. Add to the build path, and now we're hooked up with the data, not directly with the database, but we've got an implementation of the basics. Okay. I've got a film class here, right? And I've also got a function that we're going to start writing. I've got a director class here, right? We've already done this. We've already designed a film database where we've got a film, and then we've got actors, and there's a many-to-many relationship there. And then a director directs a film. They could direct many films. We're going to use that as a basis for how do we connect programmatically and load up all of the directors. How do we connect and load up all of the films that are in the database, right? And I've got that set up right now. But here's my class. Ignore all that stuff at the top. Here's my class. A director has a director ID. That's the primary key. They have a first name and a last name, and of course a film has a film ID, a title, and then a director here using composition. Not a director ID, not a director code or anything like that, an actual director object. Okay? So now what we're going to do is we're going to follow this basic 5-step process that you'll always follow. We're going to have to load up the Jdbc driver. That's the thing that actually is responsible for the low-level details of connecting to the database, passing data back and forth. We need to load up that driver, possibly. In some implementations, you don't have to do this, but I'm just going to show it to you how to do it because it's just safer to go ahead and load it up. Then you create a connection to your database, and to connect to your database, you're going to need a username, a password, and a URL to actually connect to it. You're going to have to prepare and create a query. You prepare the query, you execute the query. If it's an update query where you're pushing stuff, persisting stuff to the database, then you're not going to expect any results back because you're putting something in the database, or you're updating something in the database, or you're deleting something from the database. But if it's a select query, right, you're expecting a result set back. So if you do have a select statement, which we are going to start with here, we're going to have to reprocess that result set. Then, last but certainly not least, because if you don't do this, you will have a bad time. You have to clean up your resources. These things open up resources. A connection to a database, that's a network connection. A network connection is extremely expensive to create. It's not so expensive to maintain, but you are maintaining it. You're holding on to resources on the server. You're holding on to memory on your own computer. You're holding on to a lot of resources. Once you are done, you need to clean up after yourself. To clean up after yourself, that simply just means that you're going to close all of those resources. All right? So same 5-step process here. In fact, I'm going to bring that over here. And we're going to start with this method right here. Let me go ahead and expand this out. Load all films. I'm going to load all of the films from the database. These are my steps. So just as a reminder here, one, you know what? Nope, okay. 2, we're going to create that connection.
3, we're going to create and prepare a query that will submit to the database, and then 5, we'll clean up after ourselves here. So I'm actually going to create a list of films here. So I do want to set that up first. A list of films, right? All films, or I'll just call it films, and I'll just make this into a new array list of films, and that's what I'll eventually return at the end. Now, if I run this right now, it's not obviously going to print anything because I'm not actually loading up anything from the database. So it runs and everything works. But of course, I haven't connected to the database and pulled out that data. Right? So my first step here is going to be to load the driver. Okay, just a second here. I need the driver class. Now, what this basically means is it's something called reflection. Don't worry about that. That's kind of aspect-oriented programming, which is not object-oriented programming. But basically, I need to tell the Java virtual machine that I want you to use this particular class because I want you to connect to a MySQL database. I want you to use the class in this jar file. If I had 3 different jar files, one of them for MySQL, one of them for Postgres, one of them for DB2, then I would have to specify, well, I want this one. I want to connect to the MySQL database. Now, that's why I said that it's maybe optional, because if you only have one of these things, then you might be able to get away with it. Okay? There is the driver class that you can find in this MySQL connector jar. Right? If you download version 8.0.19, like I'm recommending, then it's in the path, the package com.mysql.cj.jdbc.driver. You just have to look at the documentation, RTM, to find out where that stuff is. That's my driver class. Now what I want to do is I want to load the driver. Let me go ahead and put one up here because that's what I'm doing. Right, there we go. What I'm going to do is this is the reflection part. So class.forName, driver class, and then you have one of 2 options here. The old school way of doing it is new instance. There we go. And it's going to complain about this because you need to surround it with a try catch. So unfortunately, and we'll talk about best practices later on, almost everything that you're going to do with JDBC is going to end up with some sort of a checked exception. Remember, those checked exceptions are the ones that you have to surround with a try catch, and you have to do something with it. The best practice, again, is just to catch and release like you would a fish. Catch, exception, E, and rethrow it as a runtime exception. Throw new runtime exception E. Why these are checked? This exemplifies the mistake with Java, in my opinion, of what the bad things that or why checked exceptions were a mistake. How can you reasonably recover from a missing jar file? How can you reasonably recover from a bad password? How can you reasonably recover from no internet connection because you're trying to connect to a remote database? You can't. If you cannot reasonably recover, then these should not be checked exceptions. This is a mistake to have checked exceptions. It was a mistake to design JDBC with checked exceptions, but it's a mistake that's 20 years old, so we have to live with it. It was a mistake that was corrected, by the way, in, say, JPA, right? Something that was made, it was a little bit more modern. Right? But that's what we're going to have to live with here. Now, this might be the first time you've seen this thing in Eclipse. It crosses it out, right? And if you hover over this, you'll see that the message here is that this has been deprecated. Deprecation means that if you've got something that's old and you want to get rid of, you mark it as deprecated. In other words, you're signaling to everybody, don't use this anymore because in the future, we might take it away. We might make it backwards incompatible. Now, this has been deprecated since, as of what? I think Java 8 or 9 or something like that. So it's been deprecated for several years, and they're still going to allow you to use it because Java bends over backwards to make sure that it's absolutely backwards compatible. You might remember on your first, or your second assignment, I guess, where if you used Xstream, you saw all those warnings about old stuff and we might not allow this in the future, right? That's kind of the same thing. That they've added features in Java in the last few years and they've deprecated things and saying it's a big signal, please change how you use Java because going forward this might not work, right? And that's what that's doing right there. It's crossing it out and saying you should not do this. Now I'm going to have to remember or look for my notes here. how not to do this. I forget. I think the preferred way of doing this now is I had to look it up. There we go. Oh, and it is Java 9. So for Java less than 9, so Java 8 and before, then you do this. Otherwise, for Java 9 plus, which is what I'm going to actually recommend that you do anyway, then you do this. And I'll go ahead and get rid of that because you'll still see that in the notes. You'll still see that in many, many examples that you might find on the internet. Okay. All this is doing is it's loading up the class in the Java virtual machine. The Java virtual machine is now aware of this driver class, and it knows to use it anytime you do database stuff. Okay. And that's, again, why I said that maybe it's optional, because if it's the only jar file there and it can find it successfully, then you may not need this. Okay. All right. Number 2, create a connection. A connection, and I'll just call it C, or con is what I usually do, short for connection. And I'll initialize it to null here initially. Let's give myself some more room here. In general, something like C or con, they're bad variable names, but in this case, it's okay because what kind of is it? That's what it is, right? You can't get any more descriptive than that. You could say that it's a connection to CSE if you really want to, but you need to make it a little bit more general than that. So in this case, con is a perfectly fine variable name because you can't get more descriptive, right? And if you do get more descriptive, then it's just more confusing. But certainly if you've got something like, I don't know, a broker type, you should be calling it broker type, not BT, or just T for type or something like that. Right? All right. To connect to a database, you need 3 things. You need a URL. You need, that's the connect, just like you typed in MySQL Workbench, where do you want to connect? You want to connect to the CSE server. You need a username. And for me, that's going to be cburk. You need a password. You can do password, but password is one word in case you didn't know. So I'm going to, it's all lowercase in this case. Username, you can go ahead and just use all lowercase there as well. URL, these are perfectly fine variable names. So you need all 3 of these things to actually connect to a database. Now, here is the URL that you're going to be using. Where is it? Yeah, there it is. So eventually, when I post these notes, you're just going to want to copy this verbatim. It's really long, blah, blah, blah. Right? Don't worry about it. This is Jdbc. I'm going to be connecting to a MySQL database, and the URL is going to be cse.unl.edu. The database that I want to connect to is cburk. And then these are a bunch of flag variables that you send onto the server. And unfortunately, they're necessary for the configuration that they've got downstairs on the CSE server. Again, this will be posted, and when I post this, you can go ahead and grab these, and it'll be fine. If you're using a super old version of a jar file, like say in labs on Wednesday, then you don't need this stuff. This stuff is for newer jar files. And if you download it directly, then yes, you do need this. Okay. My password. Uh-oh, I don't want to share that. Actually, I don't even remember what it is. Just for 156, I think it is. All right. Yeah, you've got temporary access to my password. This is why I told you not to use any password that matters to you for your database. Because if you use a password that matters to you, it's going to end up as plain text in your source code. Any LA, I can see it. If your partner can see it, just do not use a password that you care about. Now, this is definitely not bad. This is definitely not best practice. It is sufficient practice for this this assignment and this course. The way that you'd actually do this in real life, in a real situation, is that you'd have, first of all, you'd be the administrator of all your stuff, so you could actually get access to it. But basically, you have no password. You have a passwordless connection. Instead, you configure your database server to accept passwordless connections, but only from a particular server. And then you firewall everything else out. Or you set it up so that the password does not live in source code. Instead, it just lives in memory. You launch the application, you type in the password once, and then that's it. It lives in memory, yeah, but it doesn't live in source code. So those are better ways of handling it that
go beyond what we're doing here. Yeah. Yeah, well, of course, yes. Well, I mean, if you steal my password right now, yes, but I'm going to be changing it later, so don't worry. But yes, you would need to change your to your login, and that's going to be your CSE login here. And of course, your username would have to also be your CSE login. Okay. All right. Please, nobody exploit this while we're doing this demonstration. Seriously, don't. All right. All right. So what we're going to need to do is create a connection. So con is equal to the driver manager, and the driver manager knows which driver to use because we loaded it up here. It knows to use this thing up here. Dot get connection, and you provide it the URL, the username, and the password. There we go. And that creates a connection. Now it's going to complain about this because, again, everything is going to end up throwing a checked exception. So I'm going to surround this with a try catch. And you see that at this point, everything is going to start throwing SQL exceptions, SQL exceptions, SQL exceptions. My go-to is simply going to be to catch and release, rethrow it as a runtime exception. So that if I've got a bad password, in fact, let's go ahead and give it a bad password, 42, there we go. And that's going to be a bad password. I'm going to try to connect to the database. And of course, you can see that it's not going to work. Access denied. Use your password, yes, but it was the wrong password. Right? Just as a basic hello world kind of thing, we can make sure that the connection is actually running and my password is correct by simply just running this. And of course, no news is good news. Right? It didn't error out. But of course, I'm not pulling any data yet. I'm just making a connection to the database, and that connection gets reset once the program is done running. Right? There, I've created my connection successfully. 3, I need to prepare a query to run to the database. What I want to do is I want to load up all of the films as well as their directors, not all the actors yet. I'm just going to keep it simple. Right? So basically, I need to make a join. Right? I need to select everything, maybe, from film F, join. Right? Join would be fine because every film has a director. If I'm starting at the film table and going over to the director table, that's guaranteed to exist because it's a many-to-one relationship. Join director D on F dot director ID is equal to D dot director ID. Director ID. Right? And there, I've got everything. Obviously, that's not Java, is it? What do I need to do here? I need to put this into a string. So string query is equal to all of this stuff. Now you can put this all in one line, and that should be fine. Or you can go to multiple lines, like join. You can go ahead and take that down to the next level, and it'll automatically concatenate for you. You can line stuff up if you really want to. But I'm just going to keep it simple. That's my query. Right? Don't have long lines here. If you've got several joins, of course, then you can break it up however you want. This is where an IDE like MySQL Workbench really comes in handy. Write your query in MySQL Workbench first. Then copy paste that into your source code over here to connect to JDBC after you're assured that it works. Because if you miswrite a query right here, like you misspell director, right? That's going to end up being a Java error that you could have resolved simply by running it at least once in a different IDE. Okay. So there is my query. I now need to prepare this query. So prepared statement. There are unprepared statements. There are several different types of statements that you can use. I'm only going to show you prepared statements. You should only use prepared statements. If you're using unprepared statements, then you're opening yourself up to what's called an SQL injection attack, where somebody can inject their own SQL code and then start dropping tables, right? or getting access maybe to information that they shouldn't have access to and stuff like that. So my prepared statement, initially it's going to be null. Oops, home row, there we go. Now, I'm going to ask my connection to prepare the statement for me. Con prepare my statement, please, and I want you to prepare it with this query.
Now, of course, this is also going to complain about SQL exceptions. So I'm going to surround it with a try catch and do the exact same thing that I did above with a throw. There we go. Now, one of the common questions we get immediately is, why do you have to do this over and over and over again? Why can't you just have a throws declaration? Don't do that. Or why can't you just take the entire code that you want to run and then throw it into one big giant try catch? Yeah, you can do that, but then you don't have fine-grained control. If you're actually going to do real database stuff where you insert one record, insert a second record, insert a third record, but you want that all treated as one, and if the insertion of the third record fails, you want to roll it back, then you need to have more fine-grained control. So it's a good practice to get into, but yeah, I can see the desire to just have one big giant try-catch. Right? It's kind of like the God anti-pattern. If you're putting too much into a function or you're putting in too much into a class, you can also put too much into a try-catch block. Okay. I've prepared my statement. Now I need to execute that statement. To execute that statement is simply going to return what's called a result set. I've prepared that statement. rs is equal to ps.execute query. So my connection prepared the statement. My prepared statement executed the query and returned this rs, this result set. Okay. A result set is basically what you see in MySQL Workbench. If I queried a bunch of directors and a bunch of films, you would see here's the first record, the second record, the third record. It would look like an Excel table, right? With a bunch of headers and a bunch of records, one row to a row, one to a row. These are actually called rows. A result set has rows, and it starts before the first row, so that you can use the following pattern. While rs.next, then I will process the record. What rs does next does is you've got a pointer that's basically pointing to records. Here are 4 records. Initially, it's pointing to before the record. Right? Now, next will advance the pointer to the next record and also return a Boolean. That's why I'm using it in this while statement. That yes, there is a record that I am pointing to now. Next, yes, there's a record that I'm pointing to now. Next, yes, there's still a record that I'm pointing to now. But if I go next one more time, now I'm pointing past that Excel style table, and it's going to return false. There's no more records to process. So true, 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 true. What if I had 0 records, and it's pointing to the first one, and I go rs.next? Then it immediately points after an empty table telling me that there are no records. So you can use it in an if statement if you want to. If you're expecting only one record back or maybe no records, then you can say if rs.next. Right? Then you know that you have a record or you know that you don't have a record. Or you can use it in a while loop here. While you're still processing records, the first, second, third, fourth, false, now that breaks out of the loop. So rs.next not only advances the pointer to the next record, but it also gives you a Boolean telling you that that was successful or not, so that you know that when you're done processing all those records. Right? So let's process the record. Right now, within this while loop, it's pointing to one particular record. I would expect, a director ID, a director name. I would expect the film title and a bunch of other things. How do I get that stuff out of the actual record? I need to now go column by column. Right? Now, you can iterate over all the columns if you want, but I already know what the columns are. I know that one of the columns is director ID. So let's go ahead and get that. rs.getInt. And I also know that it's an integer because I designed the database. We designed the database together here, right? And it was called director ID. And by the way, I followed a consistent naming convention of lower camel casing on all my stuff, so I don't have to look back at my ER diagram. What did I name that thing again? Oh, well, it's director ID, right? You use good naming conventions, consistent naming conventions, then there are fewer points of failure. I want the last name. rs.get. Now the last name is going to be a string. It's actually, the last name is going to be a varchar, right? We don't have varchars in Java. What do we have instead? String. Right? And last name. Oops, there we go.
And then, of course, first name. What else do we have? Well, we've got a bunch of stuff, but all I really care about for the film is the director. So now I have enough to build a director object. I also want the title and I want the film ID. So let's get those things as well. Int film ID equals, and the film ID is going to be an integer. Again, consistent design means that I don't have to remember all that stuff. And I know that it's in the film table with an appended ID. And this is first name. There we go. And then what else? Title. String title is equal to rs.get string title. There we go. And the last thing was, that was it, right? Yeah. Now I have enough, right? Yeah, title, film ID. That's enough for now, right? Now, of course, if you redesigned your objects and you had more fields, then you could pull those as well. Yeah. This is the same class I already had. I'm working in the same class. I made a static method that is able to load up all films. You can put it in the class that it pertains to. I would generally maybe take this and put it into a data loader class, right? Load up all the films, load up all the portfolios, right? So like you had with, you had a data loader class that loaded up a bunch of DAT files. Well, now you have a database data loader class that loads up from a database instead. This is why we wanted you to separate stuff, because if you had data loading, data persisting, 3-4 different responsibilities in one file, that means that you're going to have to break it up anyway. When you change it to read from, instead of DAT files, you're now reading it from a database. But now, if you separated things out into 4 different files, now you only have to replace one of those. And you can use the exact same signatures on everything. All right. Okay. So I've got that stuff loaded up. And we can create our objects now. So director D is equal to new director, director, and I forget what the signature on that was. So it's going to be director ID, first name, last name. So director ID, first name, and last name. And then I can create my new film. Film F is equal to new film. I think the film ID, the title, and then the director D that I just created. And then, of course, I want to add it to my list because I want to return an entire list of all the films. Films.add F. There we go. And that was processing the result set. I should have had 4 up there. Process the result set. There. At this point, I haven't cleaned up, but I can at least show you that this works. When we run this, there were the films that we put in as a demonstration last week or whenever we did, or I guess 2 weeks ago now, before the midterm. Star Wars, American Graffiti, THX, Pan's Labyrinth, Hellboy. That might have been from another section. All right. All by some by George Lucas, some by Guillermo del Toro, et cetera, et cetera. Right? So I was able to successfully load all that stuff. Now you'll see here that the actual program has stopped, right? But I did not have good practice here. That it is possible, it's not likely, but it is possible that my connections on the CSE server are still open and waiting to hear from me. Do you want anything? Do you want any more, right? Do you want any more data to be sent over the wire? If you don't close your connections, then they might stay open. If you try to open up too many connections, then once you've opened up too many connections, then there's a limit. I believe that limit is like 30. You can open at most 30 connections at one time. If you try to open a 31st connection, then it will error out on you. Right? So make sure to close your resources and clean up after yourself. Basically, you need to close stuff. So the connection, you need to close it. Well, the result set is also a resource. The prepared statement is also a resource. So you need to close those as well. ps.close and rs.close. Why did I go in that order, by the way? What order is that versus what we did up here? I opened up the connection, I created a prepared statement, then I created my result set. Why did I go in reverse order here? The connection owns the prepared statement owns the result set.
So if you want to close stuff, if you close up the top here, then there might not be a good guarantee that the stuff below that it owns are also closed. So close it bottom up, just like the table creation. If you create a table that depends on another table, that table has to be created first. And which way do you delete them? You delete them in the reverse order. I'm closing my resources in the reverse order here. Now, obviously, this is not going to work because I need to surround it with a try catch. I'll put all three of those things in there. There we go. And then, again, catch and release. Just deal with it by catching and releasing. Another thing that you might commonly see is if it failed up above, the result set might be null, in which case you're trying to call close on it, but it'll end up being a null pointer exception. It could be that it was never opened. So another common pattern that you see is to check if rs is not equal to null. Now that avoids the null pointer exception, and rs dot is closed. Yep. And if it's not already closed, then you close it. Oops. It should be like that. Right. So this protects you from two situations. This protects you from the situation where it was never initialized and is still null. So you're avoiding a null pointer exception here. You're also avoiding the situation where it's already closed. Closing it, close it, close it, close it, close it, right? You only close it once. Right? And you can follow this pattern for all three of these things. Con, PS, 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 and con, con, con. There we go. There. That seems like a lot of boilerplate stuff, and you're right, it is. Maybe there's a way to cut down on that boilerplate kind of stuff. For example, probably if I've got two methods that are going to be making connections to the same database with the same password, same username, et cetera, maybe all this stuff could be offloaded into some sort of a factory function that does it for me. Right? And then I just ask it for new connections. I also see it's common that people try to offload this stuff into another helper function so that you're not always closing, have this, however many lines of code this is, a dozen lines of code. That's getting a little bit overboard. Right? Don't find that healthy medium spot, that Goldilocks zone where you are shifting common code off to some other class or method or something like that, but don't go so far that you then end up, I've seen it before as well, you end up re-implementing the entire JDBC API because if you find yourself writing too much code, like helper functions, rethink what you're doing. But otherwise, that's a great implementation that we're able to connect to our database. We're able to get stuff. We're able to process the information sent back, and we're able to print it out. That was for reading stuff reading stuff from your database. What about getting stuff programmatically into your database? So what I'm going to do is I'm going to create another function here, public static void insert new director. And we're going to need a couple of things here. We're going to need a first name and a last name. Why don't I require an ID? Right? Remember that director table? The director table has a director ID, a first name, and a last name. Why don't we need that director ID? It's auto-incremented. Right? In fact, if you're doing things programmatically, it's even riskier to do key management on your own. Because this will completely fail if we insert a record using the ID 10 and there was already a director with ID 10 in there. So we're going to let it handle that stuff for us. Okay, well, same basic process. You load up the JDBC driver if you need to. You create your connection. You prepare your statement, except that we're not expecting anything back in this case. We're putting a new record into the database, and so we can actually skip step 4 here, but you still need to do step 5. So at the risk of showing you bad habits here, or getting you into bad habits here, let me go ahead and don't do this. Right? Don't copy pasta. Right? That's okay in this case because I'm pressed for time. All right, so 1, you load up the JDBC driver. 2, you make your connection. Again, if this is so common that you're doing it every single time that you're going to the database, maybe you could put that into a function or a factory function or something like that. Right? Okay, that's not my query. I want to create a query to insert a new record. So help me out here. Insert into the director table. The first name, okay, comma, last name, values, oh, and then what values? Okay, well, I've got a first name and a last name up here. The first, maybe you're tempted to do something like this. Go ahead and concatenate the first name. Go ahead and concatenate the last name. Right? Don't do that. We will see why not later on. This is a prepared statement. It's going to prepare stuff for you. What I'm going to do is I'm going to put what I originally had. I don't know what you want to put in. I don't know what you want to put in. Question marks are special symbols in JDBC. Those are placeholders. Those are placeholders that are going to be replaced by JDBC with the actual last name and the actual first name. Right? The reason that you would not want to do this, not even for security reasons, what if I had an Irish last name, right? O'Rourke, right? What's going to happen with that single apostrophe? Is that okay to insert it into a database like that? Probably not. What do you do if you were in MySQL Workbench? What would you do? You would escape it using a backslash, right? Well, you can escape it here. You can write your own code to escape every single special character out there. Or you can let the database do it for you, or you can let JDBC do it for you. And you get that by using a prepared statement. We're not expecting any results back, so I'll go ahead and get rid of the result set here. Oops. Come on, there we go. I'm going to prepare my statement. And now instead of executing a query, what I want to do is I want to prepare that statement further. I want to get rid of these question marks here. I want to replace this first question mark with the actual first name, the value stored in this variable that's passed to this method. The way that I'm going to do that is ps.set. Right? Remember that we were getting all that stuff when we pulled it out of the database. Now I'm going to just simply set, and it's a string. The parameter index is going to be, and we'll come back to that in a second here, and then the first name. And I want to set the second parameter here to the last name. There we go. 1 corresponds to the first question mark. 2 corresponds to the second question mark. And if you had, like, say, 10 parameters, these are called parameters. If you had 10 parameters, then it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's in contrast to indexing, right? Indexing starts at 0. Remember that. That parameters start at 1. Now, better implementations like JDBC, or JPA, they actually have what are called named parameters. And so you could actually see something like this, like last name. This is what you would do in some other alternatives. You would have a colon, and then whatever followed the colon would be the variable that you're putting. And then you could put something like this, last name. Well, last name, first name, I've already screwed it up. But then you could name your parameters instead. But now, with just JDBC, you have to remember 1 goes with the first one, 2 goes with the second one, et cetera, et cetera, et cetera. You don't have named parameters in plain old JDBC. But it would be very nice if we did. But we have to hop into a time machine 20 years ago and tell them and slap them over the head and say, this is a bad design, don't do this. Okay. I've set the first one, I've set the second one. If I didn't set it, what would it be? Good question. It'd probably be a runtime exception because you didn't set them all. Right? So make sure that you set them all. Now what I'm going to do is I'm going to execute my query, the update. Or that's not an update, but the query. ps.execute update. There we go. Hey, that's not an update statement. That was an insert statement. It doesn't matter. In JDBC, there is only one method that you call, update, execute update. You do this for delete statements,
You do this for insert statements. You do this for update statements. Anytime that you are writing to the database, changing the database, you call execute update, and it's done. Right? Now there's a new director in there. I don't have a result set, so I can't clean that up. Otherwise, everything else is the same. Let's go over here and create a new director. Let's see, I don't know. Director dot add, or no, what is it? Insert new director. There we go. Give me a director. That's probably not in the database. I think he's there. Give me some obscure director. Oh, okay. UE Boll. There we go. I think it's BOLL. Really terrible movies from the early 2000s, right? Yeah. I don't know if he's still directing or not. Probably not. Like sub-sci-fi channel kind of movies. Yeah. Run that. Everything. No news is good news. So there's probably a director in there named UE Boll. Now, of course, it's not showing up in that output because we haven't associated any movies with him, any films with him. We'd have to write more code to do that. Right? We'd have to write code to pull out the director ID of that director, and then we would have to use that director ID to insert a new record into the film table using that ID. You'll explore how to do that in your next two labs. There is a little bit a convenience way that you can do it. You can get the last inserted ID if you really want to, but of course it's not going to work now because that would be a separate run of this program. Okay, but that's the only difference. If you're reading stuff out of the database, you follow the same 5 steps, and you process the only difference is that you process your result set. If you're inserting stuff or updating stuff or deleting stuff from your database, you simply just set up the same 5-step process without that 4th step, and you use execute update. Okay. Any questions so far on this? Otherwise, that's more than sufficient to get started on your lab tomorrow. But let's talk about best practices. So for that, I'm going to have to go back to markdown mode here so I can start typing again. So best practices. So as we saw before, dealing with SQL exceptions. Unfortunately, it's old. Jdbc is old, and it has an older design. So unfortunately, most operations throw a checked SQL exception that has to be caught and dealt with. Right? So don't worry about it. Just catch and release. Right? Rethrow the exception as a runtime exception. There we go. You might even you may even want to log the error, then rethrow it. If you do logging, then use a proper library. System.out or system.error are not proper logging libraries. And if I've got time here at the end, or maybe on Thursday, I'll show you what I mean by that. That there's a log4j library that you can bring in, which is logging for Java, and you can use that. Otherwise, there are a couple of other libraries. There's a native library that you can use without an external jar file. It's not that great. I would not recommend it. But if you're going to do logging, make sure that you're doing it right. System.error and system.out are not sufficient for that. Okay. Another item is always use prepared statements. In general, strings can contain anything, including SQL code. Right? So you could, for example, if you didn't have it's called sanitizing. If you didn't sanitize your inputs,
If somebody had a web form that went to your database backend database code, and instead of putting in their username, they put in some SQL code as their username, and you were using concatenation, and you weren't set up properly to not allow that, then and you weren't sanitizing it, then that means that by submitting this SQL code instead of a username, they can potentially execute whatever SQL code they want on your end. That's called an SQL injection attack, right? Without sanitizing your code, you have the potential, you are susceptible to an SQL injection attack, right? Where a user may be able to execute arbitrary SQL code on your database. This all goes away if you use a prepared statement. Prepared statements, not statement, but statements, there we go, in Java sanitize the inputs for you, ensuring that no SQL injection is possible. Because if the way that it sanitizes it is it sees that, oh, that looks like SQL code, I'm going to escape that so that it's not SQL code anymore. Instead, it's just a string representation of SQL code, and now you can go ahead and put that in the database, and it's not going to actually be executed at all. Right? So make sure that you are only using prepared statements. Never use anything else. Right? And also, it's just simpler to use one method to connect to a database. Right? If you're using prepared statements in one location, unprepared statements in another location, because there's no risk there at all because we don't have any parameters, you get into bad habits. You get complacent, and you eventually screw up somewhere. So it's just simpler. Just use one prepared statement. And the example that I'm going to show you for this is the classic XKCD. Let's see, where's module? Bobby tables. Yeah, exploits of a mom. There we go. Okay. There we go. So there's the classic XKCD where, hi, this is your son's school. We're having some computer troubles. Oh dear, did he break something in a way? Did you name your son Robert? And then that cuts off the rest of the SQL query. Drop table students. And then that's the unsanitized. And if you put this in, it's going to execute, and you're using string concatenation to do this. What does it do? It ends up closing that first SQL statement, executing the drop table students, and then ignoring, because this is the comment here, ignoring whatever else remains there. So he was able to inject his own code to drop an entire table. By using an unsanitized query. Yes, little Bobby tables, we call them. Well, we've lost all this year's student records. Well, I hope you learn to sanitize your database records. And this happens all the time. Programming contests, you'll see at least one team that's an SQL injection team name, and stuff like that. So this is still one of the most common attack vectors out there. Mostly with PHP. It's the bastard child of computer programming languages. But lots of bad PHP programmers out there that still write unsanitized inputs, unsanitized database queries. Now, if you set up your database properly to not allow compound queries like this, then that also protects you. But of course, if you just write good code where you're not using unsanitized inputs, then you won't have that problem. Okay? So only use prepared statements. Another best practice is, unfortunately, like I did, avoid using the star operator. Using the star operator, the SQL star operator, brings over all data even if you don't use it. So for this example, let's go back to our code over here. And if you remember our table design, we had like a release date. We had, for a film, that is. Here I just have film ID, title, and director. But in our actual database, we had like an EIDR, which is an external identifier. We had gross earnings. We had maybe runtime. We had a release date. We had like, say, 10 other pieces of data. Down here, when I pull all that data, I'm using the star operator. So all that data that I'm not ending up using because I'm only using the director ID, last name, first name, film ID, and title, it gets sent over the wire anyway. You can imagine how inefficient this is. Probably half the data that actually gets sent over the wire is being ignored at the other end. Now, if I had a large database with, say, tens of thousands of records or millions of records, and I was asking for all those millions of records, but I was ended up ignoring half the data, you can start to see the inefficiency. Networking, transmission, and bandwidth are your biggest bottlenecks when it comes to this stuff. Not memory, not processing power, but getting stuff over the wire, that's way more expensive. And so what you should do is you should avoid using the star operator and instead be intentional. If you only want the director ID, the last name, the first name, the film ID, and the title, then that's all you should bring over. That's all I want, so that's all that's going to get sent over the wire now. Let's make sure that it still works, that I didn't break anything. Oh, I did. Did I misspell something? Let's see. Column I director ID in field is ambiguous. Ah, what did I screw up? There's a director ID in 2 tables. Which one do you want? Well, I know that they're the same because I designed my database to have proper foreign keys and primary keys. But we'll go ahead and go with D on this because I aliased this down here. So it's also okay for you to alias things. In fact, let's try this out and see if this works now. All right, it still worked. But what you could do is you could alias the actual field name as director ID. It worked out in the end down here because there was only one. But if you use a keyword as director ID, then it's probably even better practice. There we go. We're still getting all that stuff. Okay. Avoid the star operator because you end up wasting bandwidth and making the connection way slower. It also protects you against changes in the database. So suppose I have my film database, and now it's a. Does everybody know the term wheres still? It's an old school pirate term. Wheres, W-A-R-E-Z, like softwares, hardwares, right? Stuff that you've stolen. You all know BitTorrent at least, right? Right. So getting wares off the internet's where you're taking intellectual property without actually paying for it, right? Suppose that I transform my nice innocent film database here to an actual pirate BitTorrent database instead, and I started storing the actual film files in my database. Right? How big are those going to be? Tell me, what's the last... You're not on camera. I'm on camera. What's the last film you downloaded? All right, nobody's going to admit to it. How big was the last film that you legitimately downloaded? Ah, there we go. 2.2 gigabytes. Right. Now, if you're using this star operator and you're designing a database, you're designing a web app to just list all the movies that you have in your collection, including the downloaded BitTorrent version, right? And you use the star operator, what's that? And later on you say, I'm going to start storing the actual large, they're called blobs, binary large objects, in the database itself. If you're using the star operator, guess what? Those 2 gigabytes are being sent over the wire. Right? When all you really wanted was the title of the film. So it protects you against, it future-proofs you against changes in the database. If somebody goes in and starts storing more data and more data, if you use the star operator, you end up pulling all that data over the wire. Right? Don't do that. Instead, oops. There we go. Ignore that. All right. Hopefully that doesn't impact the broadcast there. But anyway, that ends up killing your network connection, basically. Okay. All right. All right, so some additional issues here which we'll close on. And we won't have time to do it here, but we'll talk about log4j here next time maybe. Let me go ahead and just mark this down. We'll go over to the markdown so that it looks nicer. There we go. And oops. There we go. So security issues again. If you're a DBA, a database administrator, you can give fine-grained control to particular processes or to particular people. So now think about connecting to a database. If you've got it's called a model view controller. That's something that we'll talk about on Thursday too. If you've got an application like a web app, a mobile application that simply goes to the database to pull data and display the database, and it never needs to actually modify that data, then you really should be giving it a view instead. Because if you give that application full access, they can read, they can write, they can destroy anything in your database. Whereas if the only purpose of that application is to read stuff, then you give it a view access only. So limit what your processes can do depending on how you're designing your system. Never store information in a database unencrypted. This especially goes for passwords. Passwords should be at least hashed and with a strong hash value. But in the end, you don't want to do that yourself anyway. You use, you're all, I don't know if everybody's signed up for it yet. I don't know if students have had to sign up for it. So you log into, I don't know, MyRed. What happens? Two-factor authentication, right? They didn't write that stuff. That's handled by a third party. That's called a single sign-on system. Single sign-on, SSA or what? I think the one that the UNL uses is Shibboleth. But that all security, all identification stuff is handled by a completely different system. So if you were designing an application to be run on UNL's networks with UNL students and stuff like that, the first question you ask yourself is, how do we handle authentication? How do we handle people logging in? The answer is you don't. Right? You hand that off to a single sign-on service, and then they're responsible for maintaining passwords, maintaining security, and stuff like that. You just design your system to go to redirect a user to the single sign-on. The single sign-on then tells your application, yes, they successfully signed on, and they are the person that they're claiming to be. Right? Don't do password management yourself. Right? Just like don't do key management yourself. Let the database handle it. Let the single sign-on service handle it. Always close your resources. If you were to do this in a real application, you would have what's maybe called a connection pool. A connection pool is the most expensive thing that you can do with a connection is that initial handshake, where you are establishing that connection and then keeping that connection alive for however many minutes it allows you to keep that alive. But the most expensive part of that is actually starting it up. Once it's started up, you're not using too many resources going back and forth. You're just sending a ping back and forth. Yes, stay alive, please. Stay alive, stay alive, stay alive. I'm still listening. I'm still maybe talking later on. All right. So what you can do is you can pay for all of that up front by creating, say, 30 connections. Now, these connections aren't doing anything. What you do is you put them into a pool. And instead of making a direct connection, you ask the pool, can you please give me an available connection? If the pool is empty and all the connections are being used, then it just tells you, wait, I will give you one when I'm able. When you're done with the connection, you don't close it like we were doing in Jdbc. Instead, you put it back in the pool. So that these are 30 persistent connections that are keeping alive, and you're not paying for that startup cost and that rundown cost every time that you make a connection. You just make all those connections initially, you keep them open, you keep them in a pool, and the pool manages them for you. They hand them out when people ask, when processes ask for them. The processes hopefully will put them back in the pool, and that's a better way of handling it in practice. Of course, we're not going to go that far for your actual assignments here. You can if you want. If you want to, there's a library called C3PO that handles Jdbc connections, and you can go ahead and check that out and use that if you really want to. But otherwise, good normalization gives you is also very, very important. You want to make sure that everything is separated out into its own tables. If you've got good normalization, you're probably not going to have too many efficiency issues. Because normalization cuts down on redundancies. so that you're not storing data, the same data over and over and over and over again. And if you're not storing it over and over and over again, you just pull it across the wire once. Okay. And logging is something that we'll talk about next time, but basically in a real system, there's nobody sitting there watching a screen, right? If you've got an application that's running, nobody's sitting there waiting for a stack trace and okay, and then they jump to and they go and fix something. Instead, hopefully testing is taking care of all that for you. But otherwise, if there is a problem eventually, you need a way to diagnose that problem. And since there's nobody sitting there looking at the output that's scrolling here, what you need is a proper logging system. Something that persists to a file that this thing happened at this time, this error occurred at this time, and by the way, here is the user that caused it, here was the class that caused it, and here's all the data that you need to maybe diagnose this issue. Right? A proper logging system like Log4j or something like that will allow you to do something like that. You don't worry about going to system.out.println anymore. Instead, you can pull in this library and then you can log stuff. The reason that you want to do this is maybe you don't want to log to the standard output. You want to log to a file. Those files get really large, right? So what you can do is you can set it so that when it gets too large, saves off that file and starts a new one. Maybe you want it on a daily rolling file so that everything that happened today is in one file. Then when we hit midnight, that file is saved off and a new file is started. Maybe you want to make it so that only they'll pass 7 days, 1 week of logging data is there. You can configure all of that with a proper logging system. You can't do any of that with system.out. So we'll take a look at, and of course you can do a bunch of other stuff like metrics, auditing, stuff like that. You can put it to a file. You can put it to an email, right? If a certain level, like a catastrophic error happened, the database is down completely, then the logging system can email the database administrator. Or you can put it to a database, or you can do a lot of different things that you cannot do with just a simple system.out. All right? That's where we'll pick it up next time.